Hi, everyone. Thanks for joining me today and welcome to EJ Academy. In this video, I wanted to review an example of a geometric series. In the previous video, I talked about, what are the geometric series and how you can find the sum of the geometric series. We basically calculated the sum of geometric series in a general term, and I will post the link to that video here below in the description. So in this video, I wanted to review this example with you. As you can see on the screen, so we have a geometric series. So the terms are 5 plus 2 plus 4 to the fifths plus 8 to 25ths, and so on. So we wanted to determine if this geometric series is convergent or divergent first, and if it's divergent, then it's not going to have any sum. But if it's convergent, the problem is asking us to find the sum. So the first step here is to find the pattern and the parameters of the geometric series. So I'm going to write down the general form of a geometric series, and then the next step is to find the parameters of those terms. And after that, because we already obtained a formula for calculating the sum of the geometric series, or the test its convergence, convergency or divergency, we can use those parameters to test the series, and then finally find the sum. So let's get it started. So the general form of geometric series is this. So we have a plus a times r plus a times r squared plus dot 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 plus a times r to n minus 1 plus dot dot dot. And we can summarize this as sigma of a times r to n minus 1, n is changing from 1 to infinity. And this sum is equal to s sub n. So this is a general format of a geometric series. And so here we need to find a and r for this example. So assume the first term is a. So let's assume this is a, and this is a r. Let me write it down in this format. So let's assume this is the first term, this is the second term, this is the third term, and so on. So in that case, a should be equal to 5. And then because the second term is a times r, so assume a times r is equal to 2. And since in the line above we said a is equal to 5, then 5 times r is equal to 2. Then we can say r is equal to 2/5. So we already found a and r. Just to make sure that these are the correct values, and we can use this to represent this geometric series. Let's try to calculate the third term and the fourth term using these a and r values that we just calculated. So this third term, if we look at this general form, the third term is a r squared. So a r squared is, I'm going to substitute a and r with 5 and 2/5. So 5 times 2/5 squared, and this is going to be 5 times, so whenever you have a fraction, that is, you know, you apply the exponent to a fraction, then you can use this property that I'm going to write it on the side here. So a to b, let's say that the exponent is n, then this is going to be equal to a to the power of n divided by b to the power of n. So I'm going to use this property here. So this is going to be 2 squared divided by 5 squared. And then because I already have a 5 multiplier here, so I'm going to cancel out one of the 5s here with that. So this power goes down by 1. So the result is 2 squared is 4 divided by 5. And this 4/5 is exactly this third term here. I'm going to test one more term here. Fourth term is r cubed, and this is equal to 5 times 2 to the 5th, 2/5 to the power of 3. So I have 5, and I'm going to use this property again here. So I have 5. This is the fraction line. The numerator is 2 cubed. Denominator is 5 cubed. And then again, I can cancel out one, the multiply 5 here with one of the powers. So the power goes down by 1. And then I have 2 cubed is 8. And then the denominator is 5 squared, which is 25. And then this is the same as the fourth step here. So I'm pretty confident that so these a and r values are correct. Then so I'm going to look at this r value. This r value is a common ratio, and because this is a value less than 1, this is important. Because this is less than 1, then I can say this is this series is convergent. So you can again go back to the previous video and you know, see why the geometric series becomes convergent if r is less than 1. And this is basically is because of the equation that we obtained for the sum. So the limit of Sn when n approaches infinity is a divided by 1 minus r when absolute value of r is less than 1. And then in this case, our series is convergent. So here in this example, r is 2/5 is less than 1. Then the geometric series is convergent. And then the problem is asking, you know, what is the sum if it's convergent? So obviously this is the equation, right? So we're going to use that equation. So the sum, or for short S, is equal to a divided by 1 minus r. This is the case if r is less than 1. So I'm going to replace the numbers here. So a, the parameters with the numbers that we obtained up there. So a is 5 and r is 2/5. So 5 divided by, so 1 minus 2/5 is 3/5. And then so I'm going to so to simplify this, if you remember, you're going to multiply that by the reciprocal of whatever you have in the denominator. So I have 3/5. So I'm going to multiply 5 by 5/3. So 5/3, this is going to be 25/3. So this is the sum of this geometric series. And then, so very quick, I'm going to show you, I'm going to use Desmos. I don't know how familiar you are with this website, but this is a great website for visualization purposes. So I'm going to basically type the general form of the series that we obtain. So I think in Desmos, instead of, I know in the notebook we had S and N. N is the variable here, and S is the sum. But in the Desmos, I'm going to use instead of N, I'm going to use X. Instead of S, I'm going to use Y. So I'm going to write represent the sum as Y equals to, so if you remember, it was A, which is 5, multiplied by R. R is 2 divided by 5. And the power here is N minus 1. So I'm going to write it as X minus 1. So this is the series. And then here in Desmos, it shows as a continuous curve, but we know that N is a discrete number, is 1, then 2, then 3. So it's not a curve. We cannot just connect all the numbers together and have a curve. It's just individual dots. To do that, you just click on this gear sign here, and then click on this table sign here, and then at the bottom you see the table, and then it already shows me some dots on the graph. So because N start from 1, I have to change X and start from 1 here. So -2 change to 1, and then next one is 2, next one is 3, next one is 4, next one is 5, and I'm going to go all the way to 10. So as you can see, okay, let me do one more thing. So I'm going to remove the curve because this is not really the case here. Okay, that's great. So as you can see in the table on the left-hand side, the values start from 5, and then the second term is 2, 0.8, which is 4/5, and then 0.32, 0.128. It goes all the way to when X or N is 10. The value of S is 0.00131072, which is a very small number. And then on the right hand side, you see the dots on the graph. So they are all converging to 0. So the value of the sum S sub N, it approaches 0 as N approaches infinity. And and then so this is just a way to just visualize the geometric series or any other series that matter. So you can always use Desmos, or you might be familiar with like other platforms that you can help you to visualize the numbers. So that is it for this video. If you have any questions, so please feel free to leave your questions in the comment below this video. And if this video helped you in any way, consider hit the like button, and also subscribe to our channel and hit the notification bell for future videos. Till next video, bye everyone.